Hello everyone and welcome back to Math 127 Pre-Calculus 2. So in our previous lesson, we have studied conic sections such as ellipses. So today we will continue with another important topics which is the parabola. Okay. Alright, so you may already be familiar with parabolas from quadratic functions, but in this section, we will study parabolas using the geometric definition. So including the focus, the directrix, vertex, and axis of symmetry. So by the end of the lesson, you should be able to graph parabolas with vertices at the origin, write equation of parabolas in standard form, graph translated parabolas, and identify conic without completing the square. So let's go ahead and start with the first concept. So we know that the parabola is the set of all points in a plane that are the same distance from the fixed point and a fixed line. So the fixed point is what we call the focus, and the fixed line is what we call the directrix. So when graphing a parabola, remember that the parabola always opens towards the focus and away from the directrix. Okay, so let's take a look at another concept. Okay, that there are again two standard forms of parabola with vertex at the origin. So we do have here the y squared is equal to 4px, and then x squared is equal to 4py. Now, if the equation has y squared, then therefore the parabola either opens left or left or right. Okay, and then the equation has if the equation has an x squared, then the parabola opens either up or down. Okay, all right, now the value for p here would tell us how far the focus and the directrix away from the vertex. Okay, so that's the value for p. Now let's take a look at this example. Okay, so given here, the first example, find the focus and directrix of the parabola given the y squared is equal to 8x. Okay, so this given equation y squared is equal to 8x is already in the standard form, which is again the y squared, which is equal to 4px. Once again, I got this equation from here, okay, from the standard equation. Now, okay, so now we can see that, okay, in this case, we can see that we can equate these two values, these two coefficient in the front of x variable. So in this case, we can now say that 4p is equal to 8, and then now we can solve for p, where p is equal to 2 by dividing both sides by 4. Okay, so now because p is positive, okay, so therefore the parabola opens right. Okay, and then so in this case we can now graph the parabola. So for example, we have it here at the origin. Okay, so since p here, this would now be our vertex, and then since p is 2, therefore that would be the distance of the vertex and the focus. So we'll have it here opening on the right side. So there you go. The focus now is 2 and then 0. And then we now have a directrix that is away from the opening of the parabola. So it would be on this side. So that's going to be x is equal to -2. Okay, let me just do that once again. So remember, the directrix should always be written in equation form because it is a vertical line. Okay, and then we have here the focus, which is at 2, 0, and then this would now be our parabola, which opens on the right side. Okay, all right, so next one, let me just write that. So this would now be your directrix, which is x is equal to -2, and then focus is at 2 and then 0. Okay. All right, let's have another example. So find the vertex, focus, and directrix of the parabola given by x squared equals negative 12y. Remember, I have mentioned that if you do have x squared, then therefore either it opens upward or downward. Okay, so let me just go ahead and write that. Okay, our standard equation here is x squared is equal to 4p and then y. So with this, we can equate the coefficient in the front of y. So therefore, this is 4p is equal to negative 12. And then dividing both sides by 4, so we get a negative 3. Okay, so now since the value of p is a negative sign, therefore we say that, again, we say either up or down. So since this is negative sign, therefore the parabola opens downward. Okay, so we can now proceed with the graphing. Okay, so we know that this equation is at the vertex is at the origin. And then again, the focus now would be along with the y-axis down, since the parabola opens downward. Okay, and then up here, same distance. So that's going to be the directrix, which would be x is equal to, oops, it should be 3. Okay, let me just. And then up here, x is equal to, y is equal to 3. Since now it is a horizontal line. Okay, so now we can now proceed with drawing or sketching the directrix here. Okay, and of course, this would be our focus. Okay, and then this would now be our parabola. Okay, so there you go. Our now vertex is at the origin 0, 0. The focus is at 0, negative 3. And then finally, the directrix, we see it here, is at y is equal to 3. Okay, and then this would be the graph. All right, now moving on with another terminology here. Okay, all right, next we will now be discussing the latus rectum. So the latus rectum is a line segment that passes through the focus, is parallel to the directrix, and has endpoints on the parabola. Its length is the absolute value of 4p. So this helps us create a more accurate graph of the parabola. Okay, so in this case, let's say for example, okay, so this would be our latus rectum. So if you notice earlier that from this previous two example, okay, I just assumed that there is a curve here, but I did not measure how wide, okay, or how narrow the parabola is. So in this case, with the help of the latus rectum, so we will know how wide or narrow the opening of the parabola through this given length, okay, which is again the latus rectum. Okay, now going on to this example. So find the standard form of the equation, find the standard form of the equation of a parabola with focus at 8, 0, and then directrix, which is equal to, x is equal to negative 8. Okay, so let me go ahead with the graphing first. Okay. So we can visualize the given values here, although it doesn't say here that we need to graph. Okay, so we see that our focus would be at 8, 0. So therefore, this is along with the x-axis. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we have here at 8, 0. And then the directrix now would be at x is equal to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is x is equal to negative 8. So we know that there is a directrix here, x equals -8. And then this is our, again, focus. And then, of course, the parabola will be in between these 2 points or these 2 references. And so the parabola would be here. Okay. Now, what we're going to do is we want to know the latus rectum, okay, of this portion. So we have here that P is equal to 8. Okay, so according to the standard equation, our standard equation is y squared is equal to 4p and then x. Okay, so this 4p right here, okay, that value right there would be again determined by this given equation, which is the p is equal to 8, since that is the distance between the vertex and the focus. Okay, so therefore, what I'm going to do to make it a 4p, I am going to multiply both sides by 4. So this is now 4p is equal to 32. Okay, so now I can now write the equation. Okay, so instead of just 4p there, so we have there y squared is equal to 32 and then x. Okay, and this would now be our equation. All right, okay, so as you can see here, what would be our latus rectum here? The latus rectum would be 32. So that means to say that the parabola here, it has a width that is 32. Okay, so let me just complete the graph here. Okay, although we're not yet, once again, really graphing the latus or showing the latus rectum, okay, but we know that it has a really wide opening of that parabola. Okay, all right, so well, actually, if you are going to start with this equation, you can just simply substitute the value of 8 here, wherein we have find out that that is the distance of between the focus or the directrix. So you can go directly with that. Y squared is equal to 4px, which gives you the same result of the equation, which is the y squared is equal to 32x. In this case, I just showed you the solving backwards with what we did from the previous example. Okay? All right, now next concept. So now this time, what we're going to do is, okay, so what if the vertex is not written at the origin, okay? It's not at the origin. Okay, now let's go ahead and take a look at the parabolas that are not centered at the origin. So the standard forms, we have here the y minus the k squared is equal to 4px minus h. And then the x minus h squared is equal to 4p times the y minus k, where the h and then the k represent the vertex. So if the squared expression is the y minus k, the parabola opens either right or left. And then if the expression is has a square for the x minus h, and therefore it opens upward or downward. Okay, now let's take a look at this example. So find the vertex, focus, and directrix. From the parabola, we have x minus 2 squared is equal to 4 and then y plus 1. So then graph the parabola. Okay, so first, let's determine the vertex of this equation. We see that the vertex here would be these two values, but remember, you need to change their sign, because according to the formula here, it must be opposite of k and then opposite of h. Okay, so in this case, we now have h would be now 2, and then k would be a -1. Okay, and then next one would be, what we're going to do is to equate that coefficient in front of that linear factor, okay, or linear term. So we have here 4 would be equal to, oops, okay, let's see. Okay, so in this case, we will have 4p would be equal to 4. Okay, I got this 4 from here, and then I got this 4p from the standard equation. Okay, which is that. All right. Okay, so now p is equal to 1. All right. Okay, now let's decide whether the focus is along a vertical line or along with a horizontal line. So by looking at the equation here, since the x minus 2 is the squared, okay, not the y, so in this case, we know that the parabola opens, again, upward. And since we do have here a positive p, then therefore, again, like I've said, it opens upward instead of opening downward. Okay, so in this case now, we can now graph. Okay, so the vertex is at 2, -1. Okay, let's see if these are enough. Okay, so let's go with vertex is at 2 and then -1. And then what else? So we have here the focus wherein the distance would be 1. So therefore the focus would be here, which is at 2 and then 0. Okay, so this is the vertex at 2, -1. And then the directrix is, we will just go down here. Okay, so directrix is x is equal to -2. Okay, and so now the latus rectum, we know that the latus rectum would be this value right here. Okay, which is the 4p, which is again our segment for the latus rectum. Okay, so now I'm going to include the latus rectum here. Latus rectum, that would be along with the focus. So the focus is right here. So there should be a measurement that has a 4 units, since we have here 4 units. So we have here, this would be the endpoints of the latus rectum. So we have 1, 2, 3, 4. And so this would now be our graph. Okay. All right, so let me just go ahead and write all the information here. So we know there's a focus at 2, 0. Okay, and then we have here a directrix, which is at x is equal to -2. Oops, that should not be x. That should be y is equal to -2, since it's a horizontal line. Okay, and then next one, we have here the latus rectum. The latus rectum would be again the absolute value of 4, which is again 4. As you can see here, we have 4 units along with that focus. Okay, and so if you are going to add a more information here, it's what we call the axis of symmetry. So there's an axis of symmetry here, which is at x is equal to 2. Okay, so for now we will not be including that since the problem is not telling us to include it, but later on we will include the axis of symmetry. Okay, let's have another example. Okay, so convert the equation to standard form to find the vertex, focus, and directrix of the parabola of the equation x squared minus 8x minus 4y plus 8x is equal to 0. So, and then we will graph the parabola. Okay, so let's go ahead and start writing this. So remember, whichever variable here that is a quadratic term, so that would be the variable that we will be isolating it on the left side of the equation, and then the rest will be written on the other side. So since the case here has a quadratic term, which is the x variable, so all of the terms with x variable will be on the left side, and then the rest would be on the right side. Okay, so I will keep the x squared minus the 8x is equal to, so for the -4 and then the +8, this will be written on the other side. So this negative 4 y will become positive 4y. This positive 8 will become negative 8. Okay. All right. So next one, we now proceed with making this perfect square trinomial because we want to have a square of a binomial. Okay. So in this case, what I will do, let me just move this a little bit on the right side so I can have a space here to make it a perfect square trinomial. I'm going to use the formula b over 2 and then square. Okay, hold on my pen here. Okay, so we have here b over 2 and then square. Okay, what is the value for b? That would be the 8. Okay, so that's gonna be negative 8 over 2 and then squared. We know that negative 8 divided by 2 is negative 4. Square of negative 4 is 16. So I'll be adding 16 here. And to, again, balance the equation, I also need to add 16 on the other side. Okay, so now you can see this is a perfect square trinomial with x and then minus square root of 16. We have 4 and then squared is equal to, we have here 4y minus 8 positive 16 is positive 8. Okay, next one. On this side, we need to make the coefficient of y equal to just positive 1. So what are we going to do? We need to factor out the coefficient of y, wherein we can make that coefficient of y which is equal to positive 1. So factoring that out, so the remaining now is y plus 2. How do you know this is correct? If you're going to multiply this to each of the term, you'll go back with 4y plus 8. Okay? All right. So next one, we now go ahead and graph this by filling in the informations. Okay, so we now see the vertex here, that the vertex is at, okay, the vertex will be at 4, and then the k is negative 2. Okay, and then we'll have the focus. Okay, so the focus, you need to determine whether the focus is above the vertex or below the vertex. Okay, and then the directrix. So this one is easier if you're going to visualize it first, and then let's go ahead and include the axis of symmetry. Okay, so graphing this, so the vertex is at 4 and then 2. Okay, let's see again if these are enough. Okay, so we have here 4, 2, 1, 2, 3, 4, and then negative 2. So this would be our vertex at 4, negative 2. And then the focus here, so we need to solve for the p in order for us to solve for the focus. And since we know that the value for 4p is 4, so 4p is equal to 4. Again, I got the 4p from the standard equation, which from here, okay, that's the 4p. I am just equating it with the given value, which is again 4. Okay, so now I'll divide both sides by 4, so we get p is equal to 1. Okay, so since the 4p, for the latus rectum, by the way, for the latus rectum is equal to the absolute value of 4p. And since the 4p is equal to 4, so therefore the latus rectum is 4. Okay? All right, so next we now go ahead and count the distance from the vertex by 1 unit. So therefore, the focus would be on this side. Again, I am counting it up for the focus because the p here is positive, so I know the parabola opens upward. Okay, all right, so now this would now be our focus, which is at 4 and then negative 1. Okay, next one, so that would be our focus, 4, negative 1. Okay, next one, we now go ahead with the directrix. Directrix would be below the vertex. So therefore, just 1 unit since our, again, p-value is 1. Okay, so therefore, this is x is equal, I keep on saying x. Okay, so we have here y is equal to negative 3. Okay, there you go. So our directrix would be y is equal to negative 3. Okay, and then, of course, the axis of symmetry, since this is a vertical line. Okay, so that's going to be x is equal to 4. Okay, so now we have here axis of symmetry at x is equal to 4. Okay, and then now I'm going to draw now the parabola. I'm going to use, of course, the information of the latus rectum. Okay, so the latus rectum here is 4. That would be, again, along with the focus. So that should be 4 units in total. So this would now be the endpoint of the line segment, which is the latus rectum. Okay, so we have it here. Oops. And then on the other side. Okay, so this is our latus rectum. It's a segment that is along with the focus. Okay, so this would now be our parabola. Okay, so there you go. So that would now be our parabola for this given item. Okay, so as you can see, we have here the directrix, the focus, and then latus rectum, which is equal to 4, total of 4 units there. And then we have here the axis of symmetry, and of course the vertex. Okay, so moving on to the next concept, which is the last concept. Okay, so let's go ahead and identify the conic section. So in this case, at the end of the lesson, we will also learn how to identify conic section without completing the square. For an equation for the form ax squared plus cy squared plus dx plus ey plus f is equal to 0. So now we will identify the conic section by just looking at the coefficient for x squared and then the y squared, which we are going to name this as a variable a and then c, okay? So according to this, that if you have exactly equal value for a, then that equation gives you a circle, okay? So the equation would be a circle. Now, if you have, for example, if you're going to multiply the a and then the c, okay, if it will give you a 0, then therefore it would be a parabola. Again, if you're going to multiply a and then c, then if it is equal to 0, then therefore it is a parabola. Okay, or think about if one of this value a or c is 0, then it's a parabola. Next one, if the value for a and then c are not equal, but they have, both of them are positive, okay, or both of them have the same sign, then therefore this is an example of an ellipse, okay? The shape would be an ellipse. Again, if the two values are not equal, but then again, they should have the same sign, then therefore it's an ellipse. Now, if, for example, these two letters here, okay, so these two letters are not equal, okay, for example, they are not equal, sorry, yeah, of course, not equal. But then again, one of this is a negative sign. If one of these are negative sign, then this is an example of hyperbola. Hyperbola meaning to say, this, I know we haven't went on the hyperbola, but hyperbola looks like this. It's like a two parabola that opens on exactly opposite direction, okay? So, and also, let me just go back with the ellipse. It's also the ellipse. It's like a circle that is an imperfect circle, okay? So if the circle is a perfect shape, then those two coefficients are exactly the same in value. But if these two values are unequal, of course with the same sign, then it becoming not a perfect circle, which is now an ellipse, okay? So let's take a look at these four statements and identify whether they are representing a circle, parabola, ellipse, and hyperbola by looking at the value for A and C, okay, or the coefficient of the two quadratic term, okay, coefficient of the two quadratic term, okay, starting with letter A. So for the 3x squared plus 2y squared, I don't need to look at the remaining terms there. I just need to look at the coefficient of the two quadratic term. When I say quadratic term, that means to say their exponent is 2. So in this case, we have here the positive 3 and then the positive 2. Okay? Since we do have here that value for A, that value for A is positive 3 and then the value for C is positive 2. So as you can see, they are not equal. However, both of them are positive. Okay, they are not equal, but both of them are positive. What does it mean? It means to say that we have an ellipse. Okay, so I will no longer be writing this. Okay, I'll just be writing it in here. Okay, C A and then C. Okay, so therefore, this equation has an ellipse. Okay, it is an ellipse. Okay, next one. Okay, looking at the coefficient of x squared and then y squared, as you can see, they are exactly equal. So therefore, this is a perfect shape, which is a circle. Okay, and then next, we have here, now, as you can see, we have here y squared, and we do not have the x squared. What does it mean? So therefore, the coefficient of x squared is a 0. So like I mentioned earlier, if one of the quadratic term is 0, then therefore this represents a parabola. Okay? Since we do not have x squared here, what we only have here is the y squared only. So it's a parabola. Next one, we have here the 9 and then the negative 16. Look at those coefficients of x squared and y squared. They are not equal, and at the same time, they do not have the same sign. So therefore, this is again an equation that is a hyperbola. Okay, so again, my video was cut, but anyway, let me go back. So like I mentioned, even though you are not solving this using the completing the square, just the way we did with this example, okay, we did first, what we did is we converted it into a standard equation. But even if you are not converting it into any standard equation, you can once again identify what shape is the equation represent. As soon as you see the equation, you will see what shape they are representing. Okay? All right, so that's it for the section 9.3. Again, as always, like I always say, it's now your turn for the checkpoint part. So again, you will, on the checkpoint part, you will need to find the vertex, focus, and then the directrix of the given parabola and graph the equation. So remember, to identify the standard form first, and then find the value for P, and then use the vertex to locate the focus and directrix. Like I've said, it's easier if you're going to graph it because you are just counting the number of distance from the vertex through the value for P, or again, algebraically, you can just add or subtract that value of P to either X or Y coordinate of the vertex, depending on where the parabola is opening. Okay, so once again, in this lesson, we learn how to identify and graph parabolas using the focus, directrix, vertex, axis of symmetry, and standard form. As you complete the this guided notes and homework, pay attention to which variable is squared. That will tell you whether the parabola opens horizontally or vertically, okay? Once again, thank you for watching and I will see you on the next lesson.